Hey, all my beautiful gems, it's Miss Damaso. Today we're going to be talking about topic 10.3, which is arc and angle measures formed by chords, secants, and tangents. So this is our week 5 video 1 notes. Just as a reminder that, of course, you can find all of the notes and the homework inside of the Edmodo assignment. So if you guys want to follow along with me, either you can print the notes or you can do them in your notebook. I'm sure by now you know the drill. So let's get ourselves started on our first video for the week. So today, like I said, we're going to be talking about arcs and angles that are formed by intersecting chords, secants, and tangents. So let's do a couple examples here. When chords, secants, and tangents intersect in a circle, so inside of it, like in figure 1, on a circle, so just at one point on the circle itself, or outside of a circle, obviously somewhere on the outside, special relationships exist between the angle and the arc measures that are formed. So first one we're going to talk about is just this figure 1, when two secants or chords intersect inside the circle is what we're going to talk about. So when they intersect inside the circle, the measure of the angle formed is equal to half of the sum of the measures of the intercepted arcs. So here's what that means. In order to figure out the measure of angle 1, which is right here, I'm going to take the two intercepted arcs and I'm going to add them together. That means sum, and then I'm going to take half of them. So I'm going to divide them by 2. So the two intercepted arcs that make up this angle 1 would be this arc right here, arc AD. So I'm going to take the measure of arc AD, I put a little arc symbol over it, plus the measure of arc, the other one that makes it up is arc BC on the other side. I'm going to add those two together, and then I'm going to take half of it. So I'm going to add them together first, and then I'm going to divide by 2. And that's it. So that will get me to this angle 1 right here. To find angle 2, which is right over here, we're still going to do the same thing, except we're going to use the intercepted arcs for this angle 2. That was a little dark, kind of went over my 2 there. Whoops, sorry. So to find the measure of angle 2, one of the arcs right here that you see is arc AB. So I'm going to take the measure of arc AB, and I'm going to add it to, on the opposite side, the measure of arc DC. I'm going to add those two together, and then I'm going to divide it by 2. So I'm going to take half of it. So we're going to make sure we add first, and then we divide by 2 when we're done. Okay, so to find the angle, I add the arcs, divide by 2. Easy enough. So let's do a couple practice problems here. Let me zoom in just a little bit. Okay. So we're going to find each measure that's listed there. So the first one it wants me to find is the measure of angle AED. AED means this angle right here. Okay, so to find that angle, I'm going to take the two arcs that are opposite, that are intercepting it, and I'm going to add them together and divide by 2. So I'm going to take 45 degrees plus 109 degrees. I'm going to add them together, and I'm going to divide it by 2. So if I add those two together, I get 154. And if I take 154 and divide it by 2, I get 77 degrees. So this angle right in here, 77 degrees. Easy enough. Let's try another one. Let me change colors here. All right. Measure of angle STR. STR is this angle right here. So first I'm going to add the first arc that's intercepted, which would be this SR right here. So I'm going to add 112 plus the opposite side is 186. I'm going to add them together. I'm going to divide them by 2. So if I add those two numbers together, I get 298. And if I divide that by 2, I get 149 degrees. Simple enough, right? Number 3. Measure of angle YWX. YWX. Now, what you're going to notice here is I'm trying to find this angle over here. The two arcs that match with it would be YX and VZ. However, the numbers that I'm given are these two over here. I'm given 43 and 81. Now, if I do these two angles here, I'm going to get this angle right over here, VWY. Well, let's do that, and here's why I'm going to do it. Because I know if I add this pink angle plus the green angle, I should get a straight line, which is 180. So once I figure out this pink angle, I'm just going to subtract it from 180, and that's going to give me what my green angle should be. So to find my pink angle over here, I'm going to add 43 plus 81, and then I'm going to divide it by 2. So if I add those two together, I get 124. And if I divide that by 2, I get that the angle in pink is 62 degrees. So I should probably zoom this in just a little bit here. So this little piece right here is 62. And if that's 62, to find the green angle that's next to it, I'm going to take 180 and I'm going to subtract 62 from it. And when I do that, that's going to give me what's left over this green angle. So the measure of angle YWX is 118 degrees. Okay, so that one was an extra step, but that's okay. Remember, we always know that all of the arcs added together on the outside of the circle are going to give me 360 degrees. Let's try the next one. Measure of arc LK. Now, look at this. This time I'm asking you for this arc right here. Now remember, if you add the two arcs together and divide them by 2, you should get the angle that's on the inside. This time I'm telling you one of the arcs, one of the angles, and I want to know what the other arc is. So I know that the angle 62 is equal to these two arcs added together divided by 2. Now I'm going to put an X there, right? Because that's the one I'm trying to figure out. Instead of me having to use these letters, I'm just going to put an X there. So my equation now looks like this arc plus this arc. So X plus 74. I almost put 72. Oh my God, listen to me. Said 72 and I'm almost writing it. Come on, Mr. Masso. All right. X plus 74, and then I take that whole thing, right, and I divide it by 2. Now I'm just solving for the X. So to get rid of this divided by 2, I can multiply the whole thing by 2. And whatever I do on one side, I have to do on the other. So these 2's will cancel. If I do 2 times 62, I get 124 equals X plus 74. And then to get the X by itself, I just subtract 74. So when I do that, I get X equals 50 degrees. And I'm finished. Okay, last one for interior intersections. This time I'm asked to find the measure of arc CDE. Now if there's 3 letters, that means it's a major arc, so I want to know what this arc right here is, CDE. Okay, I am given the interior angle and I'm given the arc on the outside, so I'm going to set it up the exact same way I set up the last one. I'm going to say this interior angle equals arc plus arc divided by 2. So again, I'm going to put an X here. Arc plus arc divided by 2. So 73 plus X divided by 2. And then I'm going to solve for X just like I did in the last one. To get rid of divided by 2, I'm going to multiply by 2. And I'm going to do that on both sides. On the right, my 2's will cancel. On the left, I've got 2 times 128. That's 256. Equals, I'm just left with 73 plus X. And then to get the X by itself, I subtract 73 from both sides. I get 183 degrees equals x. And it was a major arc, so it should be a number greater than 180, right? A major arc is bigger than 180, so I know that my answer is right. All right, I'm going to skip number 6, and we're going to go on to the next section. Next section is if lines are created on the circle. So we're not talking about interior, we're talking about on the circle at one point. So if a secant and a tangent line intersect at the point of tangency, so it's the point on the circle, then the measure of each angle formed is equal to half of the measure of its intercepted arc. So you're noticing here there's like a little bit of a pattern. It's always going to be half. So we're always going to be doing some kind of divided by 2. So if I'm trying to find the measure of angle 1 right here, I'm going to find the arc that is intercepted with angle 1, and so that arc would be this section right here, AB. So to find angle 1, I'm going to take arc AB, whatever this is, and I'm just going to divide it by 2. And that's it. Easy enough. Same thing if I were to try and find angle 2 over here. I'd find the intercepted arc, and that arc would be this whole big major one here. ACB or BCA, however you want to call it here. I'm going to take the measure of arc ACB, whatever that is, and I'm just going to divide it by 2. Easy enough, right? So let's do a couple examples here and try it out. Probably find that these are a little bit easier. Okay, number 7, the measure of angle DEG. DEG, here it is right here. So I'm going to take its intercepted arc, which is GHD, this whole big thing. I'm going to take it and I'm just going to divide it by 2. So I'm going to take 308 degrees, divide it by 2. And I get 154 degrees. And that's it. Easy enough. That's when you guys always go to me. That's it? Yeah, that's it. All right, next one. Measure of angle DBC. DBC. Now look, this one's over here. The intercepted arc would be arc DB. But look, I have nothing there. However, what I do have is this arc over here. I know that this whole thing is 192, so I can figure out what this little angle is inside here. And in order to do that, I'm going to take the 192 and I'm going to divide it by 2. All right, so I've got, and I divide it by 2, and I get 96 degrees. So this piece right here is 96 degrees. Now, what I notice is that this blue angle and this green angle make a straight line. They make 180. So to figure out what the green is, I'm going to take 180 and I'm going to subtract the blue. And if I do that, I get 84 degrees. So this angle right in here is 84 degrees. So that one had one extra step, but that's okay. Easy still. All right, last one of this section. Measure of arc XY. So this time I'm looking at an arc. So XY is this arc right here, which means it's also this angle right here. Okay. Now, I kind of have two different options here of what I can do. I can figure out what this angle is and then double it to get this one over here, or I can use this whole big arc over here and do it that way. So it's kind of up to you. So here's what I would suggest. I know that this piece right here is 151. That's the blue. I know the blue plus the green gives me 180. So to find the green angle, I'm going to do 180 minus 151. If I do that, I get 29 degrees. Now, that doesn't mean this arc is 29 degrees. That means angle VXY is 29 degrees. And if I take that number, the small arc, remember the arc, the whole arc is double what's over here. So if I had this whole number on the outside, right, I would take this whole arc and I would divide it by 2 to get the angle. Well, if you have the angle, what you can do instead is I can double the angle to get the arc. So I'm doing just the opposite. Instead of dividing by 2, I'm going to multiply by 2. So I know this piece is 29, this itty bitty little angle. If I double it, that's going to give me the arc. So I'm going to take 29, I'm going to multiply it times 2. And if I do that, I get 58 degrees. So that means the measure of arc XY is 58 degrees. So you do have to use a little bit of like common sense here as you're working through these problems. Okay, almost knocked my phone over. Okay, last one is if intersections are on the exterior or the outside. So if secants and tangents intersect on the exterior of a circle, so outside, then the measure of the angle formed is equal to half the difference of the intercepted arcs. So now we have been doing half of the sum, which means adding. Half of the difference means you're going to be subtracting. So in order to find the measure of any angle, I'm always going to do the big arc minus the small arc, and then I'm going to take that and divide it by 2. So the angle is always big arc minus small arc divided by 2, and I'll show you what I mean here. If I look over here, if I want to figure out what this angle A is right here, I'm going to take the big arc that it intersects, so arc CE. So measure of arc CE. I guess I could have done it down here. Whoops. Come on, Mr. Mouse. I was like, that is not enough space for me right there. What am I doing? Okay, I'm going to do it down below. So to find the angle, I'm going to take the big arc minus the small arc. Difference means minus. Big minus small divided by 2. And that's always going to be my setup for exterior. So same thing happens with the next one. Here's my intersecting lines here. Here's my angle. My big arc is BD. So I'm going to take the measure of BD, big, minus the small is BC. Take that whole thing, divide it by 2. Same with the last one, 2 tangents. So the big one is BDC, big arc, minus the small arc is BC, divided by 2. I'm going to do that every single time. Big minus small divided by 2. So let's do some example problems here. And I'll zoom in so we can see. All right. Find each measure. So big minus small divided by 2 gives you the outside angle. So my angle is KLM. Okay. Angle KLM equals, so I'm always going to write it as an equation, the angle equals the big arc minus the small arc divided by 2. So I'm going to subtract 140 minus 66, and I get 74. I divide that by 2, and I get 37 degrees. So this angle out here is 37 degrees. Let's set up the next one exactly the same way. Big minus the small divided by 2. Now, I have the big angle right here is 67. I do not have the small angle over, I guess I should do it in the same color, the small angle over here, right? The small arc, I don't have it. But what I do have is this part over here is 94 degrees. Now, I know if it goes through the center point, right, that's why there's a point there, from one edge to the other, this whole thing should be 180 degrees. So, to find this small arc, which is what I have to do first before I can figure out the angle, to find arc BD, I'm going to take 180, which is a straight line, and I'm going to subtract 94 and 67 from it. Right, so I'm going to do 180 minus 94 minus 67, or you can do it this way. Add these two together first, subtract them from 180. If I do that, I get, so let's see, 94 plus 67 is 161. And if I subtract that from 180, I will get 19. So this small arc right here is 19 degrees. Now, to find the angle BCD, I'm going to do big arc minus the small arc, I just found it is 19, divided by 2. So 67 minus 19 gives me 48, and if I divide that by 2, I get 24 degrees. So this angle BCD all the way out here is very small. It's 24 degrees. Just a few more examples. Same sort of thing. All right. Remember again, it's big minus small divided by 2. Now, this time, I'm asked to find arc SW. So here is SW. That is the big arc, right? I don't know what the big arc is. I'm going to put an X there. So I still know that the angle is equal to big minus small divided by 2. So that's how I'm going to set it up. So the angle is equal to big minus small divided by 2, right? We don't want to forget that. It's an arc and an arc. Okay, so my angle is 40 degrees equals big is what I'm trying to find. It's my X minus the small is 75 divided by 2. And now I'm just going through because I'm going to figure out, I'm just going to solve for X. So to get rid of divided by 2, I multiply both sides by 2. 2 times 40 gives me 80. On the right, my 2's will cancel. I get X minus 75. And then my last step is just to add 75. I get that the arc, or X, whatever you want to call it, is 155 degrees. Okay, so if you know this equation, you can always plug into it. Oops, sorry. Next one, 14. Big minus angle equals big minus small divided by 2. It's asking me to find QU, which is right here. That's the big. I have the small, and I have the angle, right? So I'm going to set up the equation just like I did in the last one. My angle equals, big is my unknown, so I'm going to put an X there, minus my small arc is 46 divided by 2. Now I'm just going to solve for X. So to get rid of divided by 2, I will multiply both sides by 2. So I get 2 times 35 is 70. These 2's will cancel. And then to get x by itself, I add 46. And I get 116 degrees is my big arc. And you just want to sit there, you want to make sure that that makes sense. You go, okay, my big arc should be bigger than my small arc, right? 116 is bigger than 46, so I look like I did it right. Okay, measure of angle, KLM. KLM. I want to know what this angle is. So the angle equals big minus small divided by 2. Big is 135 minus the small is 33. Divide that by 2. So I always do parentheses first. 135 minus 33 gives me 102. And if I divide that by 2, I get 51 degrees. That one was easy. It's cake, man. Okay, skipping down to number 17 here. This time I'm asking you to find the measure of arc EF. So here is EF. Woo! Okay. First thing I want to do though is I should probably figure out what this arc is over here. This would be, I already know the angle here. This piece over here in blue would be considered the big arc, right? This would be the small arc. And this is my angle. So let's figure out the small one first, and then we should be able to figure out what this piece in orange is, because we know that a circle, the arcs always are going to add up to 360. So we should be able to figure that out. Okay, so my angle is 77 equals big is 191 minus my small, I don't know, I'll put an X there, divided by 2. Now I'm just going to solve this just like I did all the other ones. Get rid of divided by 2i, multiply by 2. 2 times 77 gives me 154. And these 2's will cancel. Now, to get the x by itself, I'm going to subtract 191 from both sides. And I am going to get, I don't know what that is off the top of my head, negative 37 equals negative x. And then to get rid of that negative sign, I'm going to divide them both by a negative 1, right? Because the negatives will cancel. And I get x equals 37 degrees. So I know the small piece is 37. Now, that's great, but I want to know what arc EF is. Now, to find that out, I'm going to take the whole thing of 360 and I'm going to subtract my 2 blue pieces, and that will give me what's left over as the orange piece. So I'm going to do 360 minus 191 and 37. Okay, so if I add 191 and 37, I get 228. And if I subtract 360 minus 228, I get that this arc right here, the measure of arc EF is 132 degrees. So I had to figure out what the x was first before I could figure out what that arc is. So you got to be really careful. You never know what pieces of information are going to be given to you. Okay, almost done. Number 18. I want to know what the measure of arc MK is. So here's MK. That looks like it should be very easy for me because this piece over here, KN, is my big. I want to know what my small arc is. I'm going to put an X there. And I already know what my angle is. So I've got angle equals big minus small divided by 2. All right, we're just going to solve this like we've been solving all of the other ones. So I'm going to multiply both sides to get rid of divided by 2 by multiplying by 2. If I do this, 2 times 56, I get 112. The 2's will cancel. I get 160 minus x. To get the x by itself, I'm going to subtract 160 from both sides. So I get a negative 48 equals negative x. And to get rid of the negative sign, because the x isn't by itself right now, I have to divide both sides by a negative, or a negative 1. My final answer is x, or the measure of MK, whatever you want to call it, equals 48 degrees. Last two. Number 19. I've got big minus small should equal my angle. Now I'm asking you to find measure of angle PQR. So I want to know what the angle is. Now, I only give you one thing right now. I tell you that the big arc is 313 degrees, but I give you nothing else. Guess what though? To figure out what this small arc is right here, what I notice is if I put my green and my orange together, which by the way, this kind of looks like a pumpkin, doesn't it? It's like green on top and orange. Okay, whatever. If I put my big and my small together, I get a full circle. A full circle is 360 degrees. So if I take 360 and I subtract the orange, I'll be left over with just the green. So I can figure out what my small arc, PR, is super easily. I'm just going to take 360 and I'm going to subtract 313. If I do that, I get 47 degrees. So that at least gives me this small one over here. And now to figure out what the angle is, right, I go back to my angle equals big minus small divided by 2. So big minus my small divided by 2. So if I subtract those two, I get 266, and if I divide that by 2, I get that the measure of angle PQR is 133 degrees. Also, I don't know if I said this, but please make sure you're putting degrees for every single one, because you know, Mr. Masso, if you don't put degrees, guess what? You get it wrong. So make sure you do that. All right, last question. Measure of angle CDE. So I want to know CDE. I want to know this angle right here. Okay, looks like I only give you one thing. I tell you that this arc right here is 106. This would be the small one. I need to know the big one right before I can do anything. And just like with the last picture, I know if I put my orange and my green together, I should get a full 360 degrees, a full circle. So to find this big arc, so that's EFC. Remember, it's a big arc, so we use, if it's greater than 180, we use 3 letters. So to find it, I'm going to take 360 and I'm going to subtract this green piece, and that will give me what's left over as the orange piece. So I'm just going to subtract 360 minus 106 degrees. And if I do that, I get 254 degrees. So now that I have that, I can do the angle equals big minus small divided by 2. So my angle equals big, minus small divided by 2. So if I subtract these two, I get 148. And if I divide that by 2, I get that the measure of angle CDE is 74 degrees. Okay, so now make sure that you understand there are 3 different equations here that we've used. We have one equation for interior. Interior, you're going to add the arcs together, divide by 2 to get the angle. Okay, so for this one here, I'm going to do a little kind of like cheat sheet here. For the interior intersections, to find the angle, you're going to do arc plus arc divided by 2. And these are intersecting arcs, right? So to get this angle, you do arc plus arc divided by 2, and that will give you your angle. If you are doing ones that are on the circle, to find your arc, or excuse me, to find your angle, all you're going to do is take the arc that it is attached to and divide by 2. That's all you're going to do. Okay, so those are 2 things definitely write down. And then the last one, oh, it's right below it. And we already wrote that. To find the angle, you're going to do big arc minus small arc divided by 2. So your angle is big arc minus small arc divided by 2. And that's a really easy way to remember them. Now make sure you remember the formula for each one, because if you use the wrong formula, you will get the answers wrong. Okay, so now we are finished with our week 5 video 1 notes. It is now time for you to go back into the Edmodo assignment and finish the week 5 video 1 homework. If you guys have any questions, please feel free to message me on Edmodo. And I think that's about it. I miss you all dearly. I hope you're all doing well. And please reach out if you guys need any help at all. Okay? Thanks so much. Have a grand day.